5.1. Today we're going to simplify expressions involving powers. Most of this will be a review from Algebra 1. This first slide, go ahead and review the different powers of exponents, different properties of exponents that we've learned in the last couple math courses, pre-algebra and Algebra 1. And we're going to just be using all of these today. First example, it says evaluate numerical expressions. So we're going to use one of the properties from the previous slide on part A. I see a product raised to a power. That tells me if I go back to that previous page, I'm going to use my power of a product. Kind of looks like the distributive property, but it's not called the distributive property. We are going to make sure that exponent 2 affects everything on the inside of the exponents. So we've got a negative 4 to the second and a 2 to the fifth to the second. We can keep simplifying that. We know negative 4 to the second means negative 4 squared, which is 16. And we also know that if we have 2 to the fifth raised to the second power, we multiply the exponents. Again, that's another property we saw on that previous page. We get 2 to the 10th. We can figure out what 2 to the 10th is next. Happens to be 1024. Multiply those together. You end up with 16,384. That's it. Part B, we're using a couple of different properties. When we're dividing two powers and they have the same base, in this case 11, we subtract the exponents. 5 minus 8 is negative 3. And again, we multiply the exponents because we're raising a power to a power. We get 11 to the third. All that's left is figuring out what 11 to the third is, either by hand or with a calculator. And we're done. At this point, go ahead and pause the video, read over the problem, and try to figure out what's going on. We've got a little bit of stoichiometry going on here. We've got some units that are going to cancel out. Not really converting units like we do in stoichiometry, but we are going to cancel things out. One thing I noticed in the problem was, so we have 85 million, and that's got a lot of zeros in it. 85,000,000. 85 million locusts per square kilometer. And we're also told that we have 1,200 square kilometers. So if we want to find out how many locusts there are total, notice when we multiply number of locusts per square kilometer times the number of square kilometers, the square kilometers will cancel out and we'll be left with number of locusts. Now, the heading of this example is use scientific notation in real life. I'd like you to try to rewrite these numbers using scientific notation. See if you get the same thing I do. The reason writing this in scientific notation is because we can kind of work through the problem a little nicer at this point. Right away, I'll go ahead and cancel out my kilometer squared. I can multiply 8.5 times 1.2, and I get 10.2. Next, I can say 10 to the 7th and 10 to the 3rd. We use our properties of exponents to add the exponents. So we say times 10 to the 10th locusts. Now, while this answer is right, this is not scientific notation, even though it kind of looks like it. We're only allowed to have the ones digit filled in scientific notation. So if you're going to write this in scientific notation, you go one more step. And the directions don't say we have to use scientific notation, so I would accept an answer like this. Or you could write out the 11 into the 11th and move the decimal over 11 places. I'm fine either way. Big numbers are often written using scientific notation, though, to save space. At this point, you can pause the video and try these on your own, or you can do that later. Next up, we're going to simplify some expressions. I've got the same base on all three pieces of B here. Go ahead and pause the video, see if you get the same thing I get. Part B is a little bit more complicated. Go ahead and try to simplify this one on your own. Check to see if your steps match up with mine. If you notice, I did not leave a -9 as my exponent. That's not considered simplified. I've got to I noticed that the 16 and the 2 canceled out to make 8, and the n to the -5ths canceled out. You could have used the property of exponents and said n to the -5 minus -5. Minus and minus makes a plus. We get n to the 0. Anything to the 0 power equals 1. So either way, they would have gone away. Next up, we've got some standardized test practice. Go ahead and pause the video. Try this one on your own as well. It's using the same properties. See if you get what I get. Once again, I see that the y's cancel out completely, just like something canceled out completely in the last example. Also, don't forget to write your answer using only positive exponents. Last example. Go ahead and pause the video. Read this and make sure you understand what's going on. Maybe try it on your own. There's a couple of assumptions being made here that might not be safe assumptions. One is that you know that a star is shaped like a sphere. If you didn't know that, you'd be totally stuck. Also, we need the formula for volume of a sphere. If you don't remember that, it's okay. I don't expect you to know it. But it turns out to be 4/3 pi r cubed. Now, if we call this the volume of the sun, r equals radius of sun, then if we want the volume of Betelgeuse, call that B, we're going to have to replace r with 1500 r. If you notice, these two formulas for volume are exactly the same except for that 1500. So that might imply that the radius, or that the volume is 1500 times bigger, but that wouldn't quite be right because this is really 1500 to the third. So you have to figure out what 1500 to the third is, and it is a huge number. Your calculator is probably going to spit out scientific notation. That's how much bigger Betelgeuse is than the sun. So it's a lot bigger than the sun. At this point, you can pause the video, try these on your own, or you can try these later. Other than that, we are done with this video.